Hi, and thank you for your question. So in this video, I'm going to answer the following question. What is the charge of an oxygen ion with 10 electrons? And I'm also going to do a few examples from the textbook in chapter 5 on from the questions 75 and 77 that you asked. So the first thing is, what is the charge of an oxygen ion with 10 electrons? First of all, you want to look at your periodic table and find oxygen, which is the atomic number 8 on your periodic table. And that means that it has an atomic number of 8, which is always going to be your number of protons and your number of electrons for a regular oxygen atom. So if I were to draw the Lewis structure of oxygen, I would know that I'd have 8 protons in the nucleus, and then my electrons would be spread out in electron shells. And the first shell can only hold 2 electrons, and then the next shell can hold up to 8. So we have 2 already, 3, 4, 5, 6, 2, 3, 4, 5, 6, 7, and 8. So that is our regular oxygen atom with 8 protons and 8 electrons. If you have an oxygen ion is not a normal atom. It is an atom that either gains or loses electrons. The proton number will always stay the same in an oxygen ion atom. So we're always going to have 8 protons, but when you have an ion, either it's going to lose some of its electrons or it's going to gain some of its electrons. Because we know that a normal oxygen atom has 8 electrons, this means that if the ion has 10 electrons, it's going to gain 2 electrons. And if an atom gains electrons, it's going to become more negative. And it's going to become more negative by the number of electrons that it gains. So that means this oxygen is going to have a charge of -2 because it's gained 2 extra electrons. So whenever you're looking at questions involving charges on ions, you're first going to want to look up the atomic number on a periodic table and then compare that to the number of electrons that they're giving you for the oxygen ion, and then decide whether you're gaining electrons, which means that it's going to become more negative, or if it loses electrons, it will have more protons, so it'll become more positive. In this case, it gained electrons, so it became -2. It became more negative. So I hope that helps with that question. I'm going to pause for a second and move on to number 75. So here I put up question number 75, which is on page 162 of your textbook. So we're looking at the end of chapter exercises for chapter 5. So for question number 5, they say determine whether the name shown for each molecular compound is correct. If not, provide the compound's correct name. So all of these compounds are molecular, which means it's going to be a non-metal combined with a non-metal. So we're not talking about ionic compounds of a metal with a non-metal. So we're not talking about ionic, we're talking about molecular. And when we name molecular compounds, that's when we're going to use the prefix numbers in front of each of the element names, and we always end with IDE. So what I'm going to do is analyze each of these names and show you whether they're correct or not and how to fix them. So this very first one, we have phosphorus and bromine coming together to create a molecular compound, and they give us our ratios of 1 to 3. Phosphorus is correct for the first part because we just use the full name of the element that's in front, and bromide is going to be the name for our bromide. We're just going to use the ending IDE. But there's a couple problems here. First of all, you don't use Roman numerals when naming molecular compounds. So that's a no-no right away. We want to take that off. And the prefix for 3 is not penta. Penta means 5. So we need to change this to tri. So phosphorus tribromide is the correct molecular name for this compound. Next, we have phosphorus and oxygen coming together in a 2:3 ratio. We have phosphorus as the first name, and it's written correctly, and trioxide, and it is 3 oxygens, so that's okay. The only thing is that we also have to include the di. So we have to show that we know that there are 2 phosphorus for every 3 oxygens. So this one was just missing the di in front of phosphorus. Next, we have monosulfur hexafluoride. It is sulfur and it is fluorine that are coming together in a 1:4 ratio. You don't need to put mono as the prefix on the first name. If it was on, if there was just one of these on the second part, you would put mono, so it'd be sulfur monofluoride if you had that, but you don't need that on the first part of the name. And also, hexa means 6. We need tetra in order to show that we have 4. So sulfur tetrafluoride is the correct molecular name for this molecular compound. And lastly, we have nitrogen and fluorine coming together in a 1:3 ratio. We don't need mono in front of nitrogen, that's assumed, and trifluoride. So this is the only one that's actually correct. So that's number 75. I hope I've clarified that. On to number 77.